In this video, we're going to solve polynomial equations. So we got 2x cubed minus 12x squared plus 18x equals 0. And we're going to solve this polynomial. So what you need to do is first take out the common factor, greatest common factor, which is 2x. So what's left over? You got x squared and minus 6x and then plus 9 equals 0. Look at this part. You could still factor what's inside the parentheses. And you end up getting x minus 3 times x minus 3 equals 0. Now you set each factor equal to 0 to solve for x. So you end up getting x equals 0, x equals 3, and x equals 3. Notice x equals 3 comes out twice. We call this type of solution repeated solution because it came out more than once. So actually the solution of this polynomial will be 0 and 3. You only need to put 3 once. And that is the solution of this polynomial. Now what we're going to do is we're going to graph this polynomial and see what happens. When is this polynomial actually equal to 0? So we have a graph of a polynomial. And when is this equal to 0? Well, it equals to 0 when x equals 0 and when x equals 3. So graphically, these are the x-intercepts of the polynomial. So you could say that the solution to the polynomial is same thing as the x values of the x-intercepts. And sometimes we call these zeros of polynomial functions. Now let's solve this equation. So what you want to do is you want to move all the terms on one side. And set that equal to 0. So what is a common factor? You take out 2x, you get x to the 4th minus 7x squared plus 12 equals 0. So you get 2x times, now how do you factor that? It's going to be x squared minus 3, x squared minus 4. And you want to double check by multiplying this out and see if you get this trinomial. Now you set 2x equals 0, x squared minus 3 equals 0, and x squared minus 4 equals 0. So here you get x equals 0. What about over here? You get x squared equals 3, which is x equals positive negative square root of 3. What about this one? X squared equals 4, so x equals positive negative 2. So actually you got 5 solutions here. You got 0, negative radical 3, and positive radical 3, negative 2, and 2. So this means when you graph this polynomial, you are going to get 5 x-intercepts. You might want to check it on your own. Now they're asking us to find the zeros of f of x equals negative 2x to the 4th plus 16x squared minus 32. When they ask you to find the zeros of f of x, that means find the solutions or x-intercepts. So how do we do that? You set f of x equal to 0, and all we have to do is solve for x. So it's very similar to what we did earlier. So how do you solve for x over here? What you do is you first want to take out negative 2. So you end up getting x to the 4th plus minus 8x squared, and then plus 16. You might want to double check by distributing the negative 2. And then what you could do is you could factor out inside the parentheses. So you end up getting x squared minus 4 times x squared minus 4. You always want to double check by multiplying this out. See if you get this. Now, this is our factorable. So you end up getting x minus 2, x plus 2, x minus 2, x plus 2. And you can rewrite this as 0 equals negative 2, quantity x minus 2, square quantity x plus 2, square. So now when you solve for x, you're going to get x equals 2 and x equals negative 2. And these two are repeated solutions because it appears more than once. So we have two solutions, or two zeros of f of x, which is negative 2 and 2. And you want to sketch this. You want to graph it and see what happens at negative 2 and 2. And let's find the zeros of f of x equals x cubed plus x squared minus 6x. So again, if the zeros of f of x is the same thing as finding the x-intercepts. So set f of x equals 0. And let's solve for x. So let's take out the greatest common factor, which is x. And you get x squared plus x minus 6. And we could still factor inside the parentheses. So you end up getting x plus 3 times x minus 2. Now we're going to set each factor equal to 0. And solve for x, so we got x equals 0. And we have x equals negative 3. And we have x equals 2. So we have three solutions, or three zeros of f of x. Negative 3, 0, and 2. And when you graph this, you're going to find out that you are going to have three x-intercepts at x equals 3, x equals 0, and x equals 2.